Okay, here we go. So I'm making a video for all of our kiddos who are absent. Do you guys care if I go and sit? Hold, I'm going to come and sit by you. Is that okay? I haven't sat in a comfy chair all day and my back is killing me. Plus, I need to keep awake. You were snoring. I heard you. Move your ish. Okay, so our first example says the square root of 3 times the square root of 3 equals 3. We know that to be true, right? If you take the square root of a number times itself, the square roots melt away, right? The square roots melt away. Well, now I'm going to show you why that happens. So if you look at this, these are actually like little fraction bars. I don't know if you guys could tell that, but the square root of 3 is the same thing as 3 to the 1/2 power. Yep. Rational means it's a fraction. So the square root of 3 is the same thing as 3 to the 1/2 power. And the rule is if the base is the same and I multiply, I add my exponents. So this really becomes 3 to the 1/2 plus 1/2. What is 1/2 plus 1/2? Well, it's 2 halves. Yeah, which is the same thing as 1. That's why that multiply, like when you multiply a square root by a square root, that's really why the radicals disappear. Don't you love that? Now you know really why it happens.
I love it.
I love it. Let's slide over to the next one. So the square root of x times the square root of x equals x. That's the same thing as saying x to the what power? 1/2 power times x to the equals x to the first because we add them. Do you guys want me to show that? I will. X to the 1/2 plus 1/2 equals x to the 2 halves, which is the same thing as x to the first, or just stinking x, right? Okay. So it says, hey, guess what? Square roots can be written as an exponent of 1/2. And that means that 2 is the index. And I'm going to write the word below it, root. And 1 is the power. And I'm going to write below that exp for exponent. Okay. 2 is the index, which is the same thing as the root. And 1 is the power, which is the same thing as the exponent. Right? So before I keep on going, these are so cattywampus because I had to staple them and they're stapled backwards. So flip it open. Yep. Sorry, this is. I stapled these backwards. Can you pass that up to Thomas? Can you pass that to Thomas? Thanks. They're stapled backwards. We're in the middle. We're in the middle section. Okay. Are we ready? Are you going ahead? Slow down, bud. Slow down. Okay. So the next one says, well, let's talk about cube roots. They're stapled weird. Sorry, it should really be like that. Let's talk about a cube root. So let's see. The cube root of 5 times the cube root of 5 times the cube root of 5 equals 5. Why? Well, that's the same thing as saying 5 to the 1/3 power times 5 to the 1/3 power times 5 to the 1/3 power. And hopefully we all know that 1/3 plus 1/3 plus 1/3 is 1 whole, right? Mm-hmm. Another example would be the cube root of x times the cube root of x times the cube root of x, which is the same thing as x to the 1/3 times x to the 1/3 times x to the 1/3. So let's talk about what that means. Well, it says, hey, guess what? So a cube root can be written as an exponent of 1/3. That is 3 is the what? What is 3? Yeah, 3 is the index. And another word for index is the root, and 1 is the power. And another word for power is exponent. Okay. So we're going to talk about what the exponent rule is. Do you guys have that exponent rule? Yeah. So our notes are a little bit differently. So I'm just going to write it off to the side. So the rational exponent rule, which is exactly what I just said. When you look at your fraction, I'm going to write 1/4. And then I'm going to do this. This means that 4 is the index and 1 is the power. That's an example with numbers because I feel like if I just use variables, it doesn't make sense. But now I'm going to give you an example. What if I said I had 5 to the m over n power? 5 to the m over n power. Well, that just means that I'm taking the what root of 5? What's going to go outside my radical symbol? What's the denominator? N. So I'm taking the nth root of 5, or yes, x over here. I heard someone say 4. I could write it, that is this. So I'm taking the nth root of 5, and I'm taking 5 and raising it to what power? 5 to the what power? M. Or x to the what power? 1. So there's a couple of ways to think about this. You can think about this way, or you can think about it as the nth root of 5, and then you take that answer and raise it to the power of m. They mean the same thing. So we're going to practice that. So I feel like our notes are totally different at this point. Pretty much. Okay, that's how I feel. So I'm gonna just write our notes out. That'll be good. So here's my first example. Yours are the same, the ones I have downloaded or not. So 16 to the 1/2 power, that just means the square root of 16. And what is the square root of 16? 4. Okay. 27 to the 1/3 power. Well, that means the cubed root of 27. Do you guys know how to do roots in your calculator other than square root and cube root? That might be something that you need. Everyone knows where to find the roots in your calculator? Okay, so let's talk about it. So if you hit the math button, you guys pick up your calculator and hit the math button. Hit the math button. Item number 4 does a cube root. Item number 4 does a cube root. Okay, but item number 5 does any root, the nth root, if you will. Okay, so F, it's a maximum and a minimum. It's just a function. Okay, so listen, stay focused. So if I wanted to know the 4th root of a number, I have to press the root, the index, the 4 before I hit the math button, number 5. I have to hit it first. Okay, we'll be able to practice that in a minute. Okay, what is -8 to the 1/3 power? What's that the same thing as? Well, it's the same thing as the cube root of -8. And what is the cube root of -8? Everybody put it in their calculator. So hit math for -8. What do you get? -2, yeah. Okay. 16 to the exponent of 0.25. Well, 0.25 is a quarter, in case you guys forgot that. So that's the same thing as saying 16 to the 1/4 power, which means the 4th root of 16. So you need to press the number 4 and then math. I want everyone to do this. And then choose 5 and it'll give you something that looks like this. And I want you to put the number 16 in it. So 4, math, number 5. 4, math, number 5. If you're not going to do it, if I can't see you physically pick up your calculator, do not come to me later and say, I don't know how to do this. Because I'll say, well, it's because you were too lazy to do it in class. It's 2. You did not get 2.5. Can I see what you did? Did you do the cube root? I want the 4th root. Okay, let me see. Come here. So you hit the 4. I said the first thing you do is type in the button 4, and then you hit math, choose number 5, and type in the number 16. Oh, okay.
2.
Got it. Okay, next. Now we're writing these as exponents. We're going to write these as exponents. So these are going to be written as exponents. Example number 1. The square root of 6 is the same thing as 6 to what power? Matt, that 6 to the 2nd power is 6 squared, which is 36. To the 1/2. Thank you, Rose. 6 to the 1/2 power. Number 2. The square root of 11x is the same thing as, you guys notice that the whole term 11x is underneath the radical, right? So that means that the whole term has to be raised to the power of 1/2. So you have to put it in a parenthesis. 11x to the power of 1/2. Number 3. I have 2 times the cubed root of y. What is under the radical symbol? Just the y. The y is the only thing that's being taken to a power. So I write this as 2 times y to the 1/3 power. How do we feel about that? Okay. So now we're going to write these as radicals. Now we're going to write them as radicals. Okay. Is everyone good with 1, 2, 3? Okay. So number 4, I have 3x to the 1/2. What number is being raised to the 1/2 power? X. So x is the only thing that's going to go under the radical. So 3 times the square root of x. Number 5, it has 4y in a parenthesis, and the whole quantity is being raised to the power of 1/2. So what's everything? Is it 1/3? Thank you. So 1/3. So what's everything that's going to be underneath the radical? Yeah, so the cube root of 4y. The cube root of 4y. Okay. Number 6 has parenthesis 5m in, and the whole thing is to the power of 1/2. So that means I'm taking the square root of the whole thing, 5m in. Is that good? Does that make sense? Mm-hmm. Yes. Do you guys feel good about that? Parker, are you sleeping on me? Yeah? Okay, so do you need to come back here and stand by me? Okay, I'm just making sure your eyes are open. Looks like they're closed. Okay, so your pictures show you like that the numerator is the exponent, the denominator is the root, the x is the base. That's what that first picture says. The second one divides it up as a radical if you look at your notes, but we are going to fill out this table together. We are going to do the table together. So your table is x to the 1/2. Then I have x to the 3/4. And lastly, I have x to the 2/3. So when I look at this first one, the 2 is my index or my root. This just means I'm taking the square root of x to the 1st power, which is just the square root of x. Does that make sense? Okay. The second one means I need the index is 4, so I need the fourth root of x cubed. And I can also write it as the fourth root of x cubed. It can be written either way. Either way, you can put the cubed underneath the radical. And there are times when you want to have it underneath, and there are times when you want it on the outside. You'll know if the root that you're looking for, if the number that's in there is a perfect root. Sometimes you'll get used to it, I promise. Okay. This last one. So what's the root or the index? 3. So I need the cube root of x squared, or I need the cube root of x, the quantity squared. Can I give you an example of when like it'd be a good idea to do this way versus, let's talk about this. I'm going to give you an example. What if I ask you for the cube root of 27 squared? So does anyone know what the cube root of 27, does anyone know what 27 squared is? Okay. Do you know what the cube root of that is? I don't either, but here's what I do know. I know that the cube root of 27 is 3. Oops, sorry, is 3, and 3 squared is 9. Okay. So that's an example of where I would take the cube root first and then square my answer, because I know what the cube root of 27 is. Okay. Otherwise, you're going to have to work with really big numbers. And you guys all don't have graphing calculators at home. And sometimes you don't have access to the internet, and it makes it hard to figure out the exact root. Okay. All right. So, yes. Can I give you a different example? Okay. So what if I said 64 to the 5/6 power? We're going to do 60. Can you guys see that? 64 to the 5/6. So that's my exponent is the fraction 5/6. So really this is asking me for what root, Corey? What's the denominator? The 6th. So I want to know the 6th root of 64 to the 5th power. Well, I don't have a clue what 64 to the 5th power is. I don't even want to figure that out. So I'm going to think of it this way. I'm going to think of it as, well, what is the 6th root of 64? And then if I take that number and I raise it to the power of 5. Well, I know that 64 is the same thing as 2 times 2, which is 4, times 2 times 2, which is 4, and 4 times 4 is what? 16. Okay. Times 2 times 2, which is 4, and 16 times 4 is 64. So the 6th root of 64 is 2. So this is just saying, hey, I want you to take I want you to take 2 and take it to the power of 5, and that's 32. Now, if we weren't able to do it like that, then I wouldn't know, like, I don't even know what your calculator does when you put in 64 to the 5th root. Oh, yeah, that's if you put it in there as a fraction. Yeah, I'm wanting to know what it does if you just do 64 to the 4th root. So I can put 64 to the 6th. What power did I want you to take it to the 5th power? Yeah, 64 to the 5th power is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is 1,073,741,824. Who wants to work with a number like that? Nobody. You do not. Okay. So there's a time to think of it a different, like sometimes we want to think of it differently. So we're now at the point where we're going to do some rewriting. So we're going to rewrite the exponent and put it as a radical. Okay. So my first example is x to the 3/2 power. So what's your root or your index? It's the denominator. I want the square root. And if we're just looking for the square root, you notice we don't put a 2 out there. We just know it's the square root. So I really want the square root of x cubed. That's what that's asking me for. Example B says, okay, well, what about y to the 9/8 power? Oh my gosh. Well, that means I want the 8th root of y to the 9th. Are you guys with me? Yep. Okay, a lot of you guys aren't writing this down. You're just staring off into space. Example C, 2x to the 4/3 power. Is 2 being raised to an exponent at all? No. So 2, and then your radical symbol. What root or index needs to be on my radical? Cubed. Good job. I'm going to slide that over and go to example D. Example D, -27 to the power of 2/3. So that's really asking me to take the cube root of -27, and then I'm going to take that answer and I'm going to square it. What is the cube root of -27? What number multiplied by itself? It's -3. -3. The cube root of -27 is -3. Okay, so this is -3 squared, which equals 9. We just did that one up in our examples, right? Example E, 2 times a to the 5/6 power. Nothing's happening to the 2. I need the 6th root of a to the 5th. Colt, are your eyes open? Mm-hmm. F. This says -6m to the -3/4 power. Well, that's a negative exponent. So that means I really have 1 over -6m to the +3/4 power, which is 1 over the 4th root of -6m quantity cubed. Oh, I hear some ohs, right?
So confused where we were getting, like, what we were, the square, like, what were times the square root y.
But does it make sense now? Are you understanding it now? Okay. So in our next round of examples, we're going to be given a weird looking radical and we have to write it as a fraction. So for these examples, we're going to go from the radical. Guys and gals, I want you to pick your heads up. I just want you to pick your heads up. Pick your heads up, every single one of you, because I can't tell if you're sleeping or not. We're going to go from a radical to a fraction. Like we're going to write it as an exponent and it's going to be a fraction. So example A, you guys with me? I'm at the bottom of page 17. 4 to the 4th root of x to the 5th. Well, this is the same thing as x to the... No, you were right the first time. Yeah, x to the 5/4. The denominator is the root or the index, okay? Example B, negative, and then I have the cube root of x squared. So let's see. I'm going to have a negative and then a parenthesis because the negative is outside. Put your x in there. And what's the exponent? 2/3. Okay. Is this making sense? A little bit. Example C. I have the 7th root of -x. Oh, wait, let me fix that because the radicals are the parentheses on the outside. I mean, it means the same thing, but still I want to show you. So I have the 7th root of -x cubed. So is the negative part of what's being taken to the power or the root? Is the negative inside the grouping? It is. So we're going to write this as negative x to the 3/7 power. Example D. Colt, I'm going to make you stand up if your head bobs again because I think I'm losing you.
I went like this.
Okay. You were shaking it. Yes. You were agreeing with me. Okay. Thank you. So 1 over x to the square root of x cubed. So because the radical's in the denominator, I know that my exponent's going to be negative. Good job. So x to the some negative power. Well, what's the exponent that x is being raised to? So that's my numerator. And what's the index of the radical? 2. This is the square root. We just don't put a 2 there. Last example here, example E, 1 over the 5th root of x cubed. So because my radical's in the denominator, I know that my fraction's going to be negative. Okay, so this is x to the, what's the power? Negative 3/5. Good job. Okay. 6, 7, 8, 9. We have 12, maybe 13 more examples, and then we're done. I think that I might have these. We're at the bottom of page 18. I'm just going to slide over. Well, no. We're just at page 18. Sorry. I'm just trying to see if I have any of these written down. No. Okay. I'm going to go back to just writing everything out. Okay. So the directions here ask us to evaluate. They ask us to evaluate. That means that you are like figuring out what the final answer is, right? It's like saying, hey, tell me what the answer is. So 8 to the 1/3 power, well, that's just the same thing as saying, hey, what is the cube root of 8? So what is the cube root of 8? 2. Okay. 16 to the 1/2 power, well, that's the same thing as saying, hey, what is the square root of 16? 4. 4 to the 3/2 power, that's the same thing as saying, hey, what is the square root of 4? And then take that answer and cube it. What is the square root of 4? 2. And what is 2 cubed? 8. Okay. 9 over 25, and the whole thing is raised to the 1/2 power. So that's the same thing as saying, hey, what is the square root of not? Oh, that's not 1/2, is it? It's 3/2. Sorry. 3/2 power. So it's like saying, hey, what is the square root of 9/25? And then take that and cube your answer. So so remember when we learned about radicals, we can break this up. We can really write this as the square root of 9 over the square root of 25. And then we can take that whole thing to the power of 3. What is the square root of 9? 3. And what is the square root of 25? And 3 cubed is 27. And 5 cubed is 125. 125. Thinking, you like it, you hate it? Hate? That's super strong. Okay.
I strongly dislike.
Okay. 32 to the negative 2/5 power. So what does that mean I'm going to do first? Drop it down. So I really have 1 over 32 to the 2/5 power. So this means I have 1 over, I need to know what the 5th root of 32 is. And then whatever that answer is, I'm going to square it. So the 5th root of 32, calculators, pick them up. Press the number 5. And then math 5. 5 math 5 and input the number 32. your math button, and choose 5, and then input 32. Let me see. So that's not what I said to do. 5, math, 5. And then type in 32.
I thought you said only 2.
No. So what do you get? 2. So I really have 1 over 2 squared, which equals what? What is 1 over 2 squared?
1/4.
1/4. Okay. Are we good with that?
Yeah.
That was the 32 to the negative 2/5. Okay, what about 81 to the negative 3/4? What do I have to do first? Drop it. So 1 over 81 to the 3/4. And that means I really need 1 over the 4th root of 81. And once I get that answer, I'm going to cube it. Well, the 4th root of 81 is, so if you press 4, press the 4, and then math 5, and type in the number 81. It's 3. So this is 1 over 3 cubed, which is 1 over 27. 1 over 27. Okay.
1/27.
Yes, 1/27. The last set of examples say to simplify. Corey, what is your question? Yeah, you can. You can go right now if you want to, and we'll just keep on trucking. Okay. So these are where you guys make your, like, typically you guys do fine with this whole writing a rational fraction in simplified form because you just use your calculator. I know you do. Even like, do you know what I mean? You just, of course you do. This is where we make silly mistakes because you can't put a variable term in your calculator, right? The calculator doesn't understand x squared times x to the 1/2. So you have to think about exponent rules. X squared times x to the 1/2. Well, the rule says that if the base is the same, we add the exponents. So I really have the exponent of 2 over 1 plus 1 over 2. And I know that if I want to add fractions, what do I have to do? I have to have a common what? Denominator. So this 2 over 1 has to be multiplied by 2 over 2. So I really have 4 over 2 plus 1 over 2, and that's what x is being raised to, x to the power of 4 over 2 plus 1 over 2. But what is 4 over 2 plus 1 over 2? So x to the 5/2. And what does that look like? Well, that looks like the square root of x to the 5th power.
So, why do you have to get a GCD?
Can you say that all again? Because you can't add fractions without a common denominator, right? Does that make sense? Okay. So let's look at example B. 3m to the 1/2 times 5m to the 1/3. Well, I can do the 3 times 5. What is that? 15. And then my power of m is going to be 1/2 plus 1/3. So what is the greatest common denominator? Or it's actually, I want the least common denominator, yeah? So it's 6. I need a denominator of 6. So how do I change this 2 so it becomes a 6? Yeah, you have to multiply by 3 over 3. So that gives me 3/6 plus 2/6. Yeah. So this actually equals 15m to the 5/6. Yes. Which is the same thing as 15 times the 6th root of m to the 5th power. I think the air conditioner just kicked on over here. I feel like the air conditioner just kicked on. Example C. It says x to the 1/2 divided by x to the 1/3. Well, when I divide, I subtract. So 1/2 minus 1/3. Well, we just figured out that 1/2 is the same thing as 3/6, right? So I have x to the 3/6 minus, and 1/3 is 2/6. So what is 3/6 minus 2/6? So x to the 1/6 power, which equals the 6th root of x. Example D, 24x to the 1/3 over 6x to the 1/2. What's 24 divided by 6? 4. X to the 1/3 minus 1/2. Well, we've worked with 1/3 and 1/2 twice now. This will be the third time. Well, hang on a second. So this becomes 4 to the x. That's 2/6 minus 3/6, right? Do you see that? 1/3 is 2/6. 1/2 is 3/6. Yeah, so this becomes 4x to the negative 1/6, which means I have to drop it. So it's 4 over x to the positive 1/6, which is the same thing as 4 over the 6th root of x. What is example E? What is the answer to example E? Yeah, negative 7x to the 1/2, all raised to the power of 0 equals 1. Example F. I don't know why I put that like that. Example F. I have x to the 1/2, x to the negative 1/2 times y to the negative 1/3. So that's really 1 over x to the 1/2 power times y to the 1/3 power. Are the bases the same here? No, they're not. So we're going to write it as 1 over the square root of x times the cube root of y. So you can't multiply different indices. Like if the index isn't the same, if you don't have 2 square roots or 2 cube roots, you can't multiply those together. They have to have the same index. Which is why we're changing them to have a common denominator. We're affecting the index, making it the same. Does that make sense, you guys? Yes, maybe no?
Yes, so.
Okay. G, x squared y to the 1/3, all raised to the power of 3. Okay. So I have a power on the outside. I have to distribute that. So 3 times 2 is 6. And 3 times 1/3 is 1. So that's what that becomes. Just x to the 6th y. X to the 6th y. And our last one, example H, I have m to the 3/2 power times n to the 3/8 power, all to the power of 2 over 3.
Is it like n and n 1/4?
Yes, but we're going to turn that n 1/4 to what? A radical.
Oh, we will know.
Okay. So I'm going to write this out so you guys can really see what's happening. So I have 3/2 times 2 over 3. That's the m power when I distribute that. N is 3 over 8 times 2 over 3. Okay. Well, 3 times 2 and 2 times 3, that gives me 6. So this is just m to the 6 over 6, which is m. Do you guys remember how to cross reduce? Did you ever learn that? Cross reducing your fractions? Okay, that's fine. We'll keep multiplying straight across. So this becomes n to the 6th over 24. But what is 6 over 24? 1/4. Okay. And m is to the first power and n is to the 1/4. So that's just the same thing as saying the 4th root of n. And that is how that looks. Yes. Yes, you may. Your homework is page 19. All of them. All of them on page 19.